Okay, so we have this last section of chapter 8, uh, and this is gonna pull everything together that we've been working on actually for the past two chapters, chapter 7 and chapter 8. Chapter 7, remember, was a lot of factoring, and chapter 8 has been dealing with all of these rational expressions. Now, in section 8.4, we're going to be solving rational equations. So we're going to be solving equations that contain these algebraic fractions. And whenever you have an x or any type of variable expression in the denominator, you have to be careful, okay? For example, if we have just 3 over x, or if we were to have, let's say, 3 over x minus 5, or if we were to have, let's say, x plus 1 over x plus 6. We have to be careful about what x equals. And we actually saw this in our very last section of chapter 4, which takes us all the way back actually to our first test. When we are solving for x and the variable is in the denominator, remember, we have to be careful about what x could be, because there are certain restrictions on the variable x in this particular case. Because remember, never can you have a denominator of 0. So in this first rational expression, one thing we know for certain is that x can't equal the number 0, because remember, 3 divided by 0 is undefined. So of all the values of x can't be 0. In our next one, 3 over x minus 5, once again, what concerns us is this algebraic expression of x minus 5, and that can't equal 0. In which case now, if we were to add the 5 over, we know x could be any number except the number 5. That would be a restriction, because if it was 5, 5 minus 5 would give you a 0 in the denominator, and that would be undefined. Let's take a look at this third rational expression. Don't concern yourself about the x plus 1. X plus 1 could be anything. Once again, it's the denominator that concerns us. The x plus 6 can't equal 0 once again. And if we were to get x by itself by subtracting the 6 over, once again, we would be now able to say that x could be any number except negative 6. That would, in fact, be the restriction on these rational expressions. So what concerns us, once again, is the denominator. Let's say we had this, x minus 8 over 2x plus 3. And we want to know what the restriction is going to be. Well, once again, it's a matter of the denominator that concerns us. We don't care about that x minus 8, okay? But we do concern ourselves with the 2x plus 3, because that algebraic expression could never equal 0. And so now, by subtracting the 3 over, we would get 2x could not be equal to a negative 3. And lastly, now we would have to divide both sides by the 2. And so x could be any number except that negative 3/2. That would be the restriction on this fourth rational expression. And this concept of restrictions is going to be necessary in section 8.4, where once again we talk about solving rational equations, which means once again we are solving equations that have algebraic fractions. And so I'm going to give you a series of steps to follow when solving rational equations. And the very first thing that you're going to look to do is, of course, everyone's favorite skill, to factor any denominator. If you look at your denominators and you see that you have a denominator that is a polynomial that can be factored by any means that we know of, making sure that it's in descending order, that your leading coefficient is positive, if there's a greatest common factor, if it's a 4-term, 3-term, or 2-term polynomial. All those different types of factoring you're going to take a look at first, and you look at only the denominators. And if you have any denominators that is factorable, you want to factor it first. Step 2. What you want to do is identify any restrictions. That's what we were just talking about when we began this lesson. We first want to figure out what x can't be before we go and figure out what x can be. And the way we do that is we're going to look at the denominators, and if you have a variable in your denominator, you're going to have a restriction. So you want to identify those restrictions before you go any further. Step 3, what you want to do is now identify the lowest common denominator. And that has been a concept that we've been working with now for the past couple of lessons. We talked about the lowest common denominator when we were adding and subtracting fractions. We talked about the lowest common denominator in the previous lesson when we were looking to simplify the complex fractions. And now once again we're going to look to identify that lowest common denominator, because that's going to help us in step 4. Step 4, we now want to multiply by the lowest common denominator, because once again, what will that do for us? That will clear the fractions. Since I know most of us don't like working with fractions, what we're going to do is use step 4 to clear out all of those nasty fractions, making the problem easier for us to solve. Step 5 is then, of course, to solve for the variable. After all, that's what we do when we solve equations. So here we are in step 5. We need to solve for the variable. There is a 6th step, one that is often overlooked. Except I know you're not going to overlook it. You're going to remember that in step 6, what you want to do is in fact check for what we call extraneous solutions. Extraneous solutions are extra solutions. And to check for extraneous solutions, what you're going to do is you're going to see step 2. And what was step 2? Step 2 were the restrictions. Okay? A lot of times people forget about step 2, and that's why people forget about step 6, because they are related to one another. Okay, now that we have our 6 steps to solving rational equations, let's try some examples. Remember, the directions will simply state solve for x. So let's start. We have the fraction 5/6 plus 1 over x minus 4 is going to equal 8 over 3x minus 12. Okay, here's our rational equation. It's an equation that contains algebraic fractions. Let's go through our steps. Step 1, we want to factor any denominator. Well, I can't do anything with the first denominator, 5/6. I'm going to leave that alone. I can't do anything with the second denominator, 1 over x minus 4. I'm going to leave that alone. This third fraction, however, as I look at the denominator, I see that it does in fact have a common denominator. So I'm going to factor out that common denominator of 3, and that will leave me with an x minus 4 in the parentheses. Okay, so that takes care of step 1. Step 2, identify any restrictions. Well, if we have an algebraic expression in the denominator like we do here and here, happens to be the same algebraic expression, we're going to have restrictions. So let's identify them. Well, if x minus 4 can't equal 0, by adding the 4 over, we know that x can't equal a 4. That's our one restriction, okay? So we can eliminate it. We know that's not going to be a solution. Next, step 3, we want to identify the lowest common denominator. Well, let's take a look here. I have the number 6 and I have the number 3. I need the smallest number that both 6 and 3 can go into evenly, and that happens to be the number 6. But we also have this x minus 4. Remember, each different denominator needs to be represented, so I need to also represent the x minus 4. That is your lowest common denominator. Now, step 4. We want to get rid of these fractions. Okay, who wants to work with fractions when it could be so much easier to get rid of them, to clear them out? And the way we clear the fractions in step 4 is to take the entire equation and we want to multiply by this lowest common denominator. So I'm going to show that step. Okay, I'm going to take the lowest common denominator and I have to multiply it with the first fraction, 5/6. Then there's the plus sign. Then I have to multiply the lowest common denominator with, of course, the second fraction, 1 over x minus 4, equals. Then we have to multiply the lowest common denominator with that final fraction, 8 over 3 times x minus 4. Let's see what happens when we actually perform the multiplication now. I'm going to multiply here, here, and here. When I perform this multiplication, my 6's will simplify, and I am left with a 5 times x minus 4 left over. I have the 5 here times the x minus 4. Then there's a plus sign, so let's put it in. Next, I have to multiply these two, in which case the x minus 4 on the top and bottom will simplify, and I am left with a 6 times 1. Then there's the equal sign. Now let's multiply these two together. Well, the x minus 4 that's on the top and bottom will simplify. 3 goes into 3 once, and 3 goes into 6 2 times. So we are left with, of course, 2 times 8. And as promised, we cleared all the fractions. Now let's, of course, go and solve for the variable. I will start by distributing the 5. 5x minus 20 plus 6 times 1 is 6 equals 2 times 8, 16. I'm going to simplify. I will now have 5x minus 14 equals 16. By adding the 14 over, that would now give us a 5x equals 30. And if I divide both sides by 5, we in fact get x equals 6. Now, don't forget there is a sixth step. We want to check for extraneous solutions. And it says to do that, see step 2. So here in step 2, we indicated that x can't equal 4. Here we're saying x equals 6, and that's perfectly fine. So we have found our one solution, 6. Okay? Lots of steps here, not going to lie. But if you take your time, work through them, okay, go through each of the steps, you should be in good shape. Let's try a second one. Let's say, for example, we have 6 over x minus 3 plus 5 equals x plus 3 over x minus 3. Now this one's not so bad because actually step 1 we don't have to worry about, because if I look at my denominators, I have the denominator x minus 3, nothing to factor. I have a denominator of 1, nothing to factor. and I have the same denominator, x minus 3, nothing to factor. Step 2, we do have one restriction. Since we know x minus 3 in the denominator can't equal 0, therefore we know x could be any number except the number 3. That's the restriction. Because 3 would make a 0 in the denominator, and a 0 in the denominator is undefined. Next, step 3. Let's identify the lowest common denominator. The lowest common denominator, as I look at my denominators, the lowest common denominator is simply x minus 3. Now in step 4, once again, what I have to do is go and carefully distribute the lowest common denominator with all parts of the fraction. So let's do that. I have x minus 3 times 6 over x minus 3 plus 5 times x minus 3 equals x plus 3 over x minus 3 times the x minus 3 lowest common denominator. So I carefully distributed. Okay, now let's see what happens when I actually perform the multiplication. When I multiply here, the x minus 3 on the top and the x minus 3 on the bottom will simplify. And I'm left with just 6. Plus, here I will distribute my 5, giving me a 5x minus 15 equals. Over here, when I multiply these two together, once again the x minus 3 top and bottom do simplify, and I am left with an x plus 3. Okay, and as promised, we wanted to clear those fractions, and sure enough we did. Now we're up to step 5. We want to solve for the variable. Here on my left side, I have the like terms. So I have 5x. This, of course, would give us a minus 9 equals x plus 3. I'm going to subtract the x over, and I'll add the 9 over. And this would now give us, whoops, jumped there. We would now have a 4x equals 12. And now solving for x, we get x equals 3. But hold everything, okay? Don't forget about step 6. And step 6 tells us to look at step 2. Now here in step 2 we said x can't be 3, and now here we are saying x equals 3. No good, okay? That is a contradiction, okay? So when the value of x that you get is your restriction, what happens, what you have to say then is no solution. Okay? So that is the importance of identifying, first of all, what your restriction is, and then checking it after you have solved for the variable. Because it can happen where we saw a problem, the very first one, where the variable that you got was not the restriction, so that's why it was the answer. But here, the variable that we got was the restriction, and that's when you write no solution. Okay? Let's try another one. Let's say we have the following. Let's take a third. Come down here a little bit. Let's take a third minus 1 over x plus 2 equals x plus 14 over 3x squared minus 12. Okay, now this is going to be a fun one. Okay, step 1. First thing that we have to do is take a look at the denominators and see if anything can be factored. Well, I can't do anything with the 3. I can't do anything with the x plus 2. This, however, okay, look closely at it. I could do quite a bit of factoring. For starters, I could take out a common factor of 3. And if I factor out the 3, we're left with x squared minus 4. But that is still factorable, okay? In which case now, because I have the difference of two perfect squares, once again, I'm going to leave the first fraction, a third. I'm going to leave the second fraction, 1 over x plus 2. But when I fully factor this third and final denominator, I have to have the 3. And since this is factorable, I'm going to factor it down into an x plus 2 and an x minus 2. So this is the fully factored form of the denominators, okay? That completes step 1. Step 2, let's identify the restrictions. Notice I pluralized that, restrictions. And that's because I actually have 2 restrictions. Because the x plus 2, that can't equal 0. And if I solve, we would get x can't equal negative 2. That's one restriction. But we also have this x minus 2, in which case, since x minus 2 also can't equal 0, and if we were to add the 2 over, now we also get that x can't equal a positive 2. So now we have 2 restrictions that we have to be careful of. Step 2 is done. We move on to step 3. In step 3, we are looking to identify the lowest common denominator. Remember, each different factor in the denominator must be represented. So I have a denominator factor of 3 here and here. That has to be included. I have an x plus 2. That's different. We have to include that. Then we also have a different factor of x minus 2. We have to include that. So 3 times x plus 2 times x minus 2, that is your complete lowest common denominator. And now once again, what I have to do is I'm going to multiply all parts of my equation by the lowest common denominator. So let's see what that's going to look like. I have the lowest common denominator of 3x plus 2 times x minus 2, and that has to be multiplied with the first fraction, 1/3. Then there's a minus sign. And then I multiply the lowest common denominator of 3x plus 2, x minus 2, times the second fraction, 1 over x plus 2. Then there's an equal sign. And I have to multiply the 3x plus 2, x minus 2, times that last fraction. And I'm going to run out of room maybe. X plus 14 over 3x plus 2, x minus 2. Okay, write small. Now, let's actually go and perform the multiplication, and hopefully this will clear the fractions. So I start here. When I perform this multiplication, the 3 in the numerator and the denominator will simplify. What remains, let's take a look here. What remains is the x plus 2 times the x minus 2. That's all that's left. Then there's a minus sign, so let's bring that down. Next, we have to perform this multiplication. And if I perform this multiplication, the x plus 2 that's on the top will simplify with the x plus 2 that's in the bottom. And what remains is the 3 and the x minus 2. Then we hit an equal sign. Next, we have to perform this third multiplication. The 3's will simplify, the x plus 2's will simplify, as well as the x minus 2's will simplify. And what remains on the right side of the equal sign is simply the x plus 14. Okay. So now, as promised, after we have completed step 4, we have eliminated all those fractions. So now we're up to step 5. Let's see what's going to happen here. When I perform step 5, okay, to solve this, here I recognize that I'm going to have to multiply these two polynomials together. That's that foiling. Then over here I will have to distribute the -3. Okay, the right side is already simplified. So if I take a look here on the left side of the equation, let's start by multiplying x plus 2 times x minus 2. What do we get but x squared minus 4? And when I distribute the -3, you get a -3x plus 6 equals x plus 14. Now, let's take a look at this red equation now for a second, because now it's a different kind of an equation. In the previous two examples that we did, we were left with a linear equation to solve. But here in this third example, we're left with a quadratic equation, okay? Remember how to solve quadratic equations that we did back at the end of chapter 7. To solve a quadratic equation, we need to have one side, remember, equal to 0, because we have to be able to factor, okay? So on the left side, I have x squared. I have a minus 3x. And when I combine my like terms, we get a plus 2 equals x plus 14. Since we need to have one side, the right side, equal to 0, I'm going to subtract x over and subtract the 14 over. When we do that, we now have x squared minus 4x minus 12 equals 0. Now we have our quadratic equation set equal to 0. Remember, now we want to factor. We began by factoring, and now we're ending with factoring. Factors of x squared, x and x. What do we know about the signs? They have to be different signs. The factors of a -12 that would add up to -4 would have to be 2 and -6. And so now we would use the zero product property. The zero product property tells us to take x plus 2, set it equal to 0, as well as taking the x minus 6 equal to 0. And so now let's go and solve for each x. I'll subtract the 2 over, and we get x equals -2. If I add the 6 over, we now get x equals 6. So we have found two solutions. So now let's finish off this problem by doing step 6. We want to check to see is either or maybe both extraneous. And for that, we need to check step 2, which was all the way back up here. Earlier, recall, we said x can't equal -2 and x can't equal a +2. Well, we have one contradiction. Here, this is saying x equals a -2. That's not a possibility based upon our earlier restriction. However, x equals 6. That is a solution, okay? So we saw now 3 cases. Our very first problem that we did, we got one solution and it worked. In our second example, we got one solution and it didn't work because it was the restriction. In this third example, we saw that we got 2 solutions for x, but only one of them worked. Okay? It is possible that if you get 2 solutions, that both might work. But as we see here, that it's possible that if we get 2 solutions, that maybe only one of them will work. Okay? I have one more thing to show you. A easier kind, actually. Okay, so this last example, you should not mind. In the examples that we have done prior, those 3 problems that we did, on the left side of the equation, we were either adding or subtracting some fractions. I call your attention to the very first problem, okay? In the very first problem, we were adding two fractions. In the second problem, we were adding two numbers on the left side of the equation. On the third problem, we were subtracting two quantities on the left side, okay? And if we have adding and subtracting, like we did in the previous three problems, you have to go through the 6 steps. But what if we have a rational equation that looks like this? Let's say we have 3 over x plus 1 equals 4 over x minus 2. This is a special kind of rational equation. What makes this special? Well, unlike the 3 previous problems, nothing on either side of the equation is being added or subtracted. What we have here is one rational expression equaling another rational expression. And this has a special relationship. We call this a proportion. You may have heard that term before. And excuse me. If you have a proportion, if you have a fraction equaling a fraction, you don't have to go through all of the steps that we did in the 3 previous problems. When you have a proportion, all you're going to do is to cross multiply. Okay? What does that mean when I say cross multiply? Well, you're going to take the numerator on the left and multiply it with the denominator on the right. So you're going to have 3 times x minus 2. We did that cross multiplication, but then we also have to cross multiply by taking the numerator on the right and multiplying it across with the denominator on the left. So I would have 4 times x plus 1. Okay? So you cross multiply whenever you have a proportion. Once again, we multiply the numerator on the left with the denominator on the right. And then you multiply the numerator on the right with the denominator on the left. Okay? Now that we have done that cross multiplication, let's go and solve. I'll start by distributing my 3. 3x minus 6 equals, distribute the 4, 4x plus 4. Of course, now we want to solve for x. I'm going to continue to get x on the left side, so I'm going to subtract 4x over, and that would give us a negative 1x minus 6 equaling 4. And then, of course, I need to add the 6 over, producing now negative 1x equaling 10. And so now, to solve for x, the last thing that we would need to do is to divide both sides by the negative 1, in which case now we have x equals a negative 10. And that would be your solution to solving that proportion, that special rational equation. Okay? Only with proportions can you cross multiply. Otherwise, if you don't have a proportion, I'm going to strongly recommend that you go through the 6 suggested steps that I gave you way back at the beginning of our lesson. And here they are. Okay? Factor any denominators, identify any restrictions, identify the lowest common denominator, multiply by the lowest common denominator to clear the fractions, solve for the variable, and then don't forget to check for extraneous solutions. That completes section 8.4 as well as chapter 8. Okay. Try the homework that goes along with this section, and if you have any questions or concerns, email me. Hope all is well, and I'll talk to you soon. Till the next time, be well.